Okay, simplify expressions with roots. But first, let's look at some definitions here. The first one, given positive number a, the positive or principal square root of a is the positive number b such that b squared is equal to a and is denoted b equals the square root of a. So for instance, what they're saying there is because of the fact that if you square 5, for instance, because of the fact that 5 squared is equal to 25 like it says on that chart, that leads to the number fact that the square root of 25, the square root of 25 is the number 5. It's the number that you square and it equals 25. The reverse fact is that the square root of 25 is 5. On the other hand, when I say the square root of 25, what I'm saying is the positive or principal square root of 25. Because also, if I multiply negative 5 by negative 5, I also get 25, as you can see here. Negative 5 squared is also 25. Negative 5 times itself. So that means that the square root of 25 could also be negative 5 based on the definition. But instead of using this symbol to represent the negative one, they put a minus in front of the symbol to represent the negative square root of 25, which is negative 5. So when you see that radical symbol with something under it, they're specifically talking about the positive one. But there is also a negative square root of 25, and you have to take that into consideration in a lot of applications. Something else I want to point out here is that when we look down here, we see the variables being squared. So let's see, if I square x, I get x squared. If I square x squared, I get x squared times x squared is x to the 4th. If I square x to the 3rd, I get x to the 3rd times x to the 3rd. You add the exponents, and 3 plus 3 would give you x to the 6th. And the same here, x to the 4th, if you square it, x to the 4th times x to the 4th is x to the 8th. So those are the squares, and we discussed actually a little bit of the second definition. Given positive number a, the negative square root of a is the negative number negative b such that negative b squared is equal to a, just like we said with negative 5. And because negative 5 squared was equal to 25, that means that negative 5 was the negative square root of 25. We went through that. And then we're going to expand it. We're not just going to talk about square roots, we're also going to be talking about nth roots. So if b to the n equals a, so now we're not just raising to the 2nd power, but to the nth power. If b to the n is equal to a, then b is the nth root, not square root, but the nth root of a. The nth root of a is written this way with a radical, with a little n up here. That little n is called the index of the radical, the index of the radical. So for instance, we know that 5 to the 3rd power is equal to 125. And it says so right here on this list. 5 raised to the cube or 3rd power is 125. So that means, yeah, it goes the other way, that the cube root, where I put a 3 up here, of 125 is equal to 5. So that's pretty much working out the same way the square root did. And the other case, for instance, let me see, let's try one of these here. If it were the cube root of negative 64, for instance, the cube root of negative 64, well, that's negative 4, because negative 4 times itself 3 times is equal to negative 64. Negative 4 cubed is negative 64, so that leads to this fact down here. All right, so knowing the powers of numbers will help you with roots. Knowing the powers of numbers will help you with roots. All right, let's take a look at number 1 on this lecture notes worksheets here. Number 1, question 1, simplify the radical. So when I see this, I'm thinking the square root of 64 is the number that when I multiply it by itself, I get 64. So the square root of 64, the number I multiply by itself to get 64, is 8. So I just put in 8, submit, and that should be it. All right, folks.